Hey everybody, this is going to be a quick video on polynomial division, which is, as the name implies, dividing one polynomial by another. This is useful for finding zeros of a polynomial, finding factors of a polynomial, determining whether or not something, a given value is a zero of a polynomial. So yeah, it's pretty useful for solving polynomials for their roots. All right. So suppose that we're given this question. We have this rational function and we want to write it in quotient and remainder form. So the rational function is, if this thing will focus, x cubed minus 3x squared plus 5x minus 6 over x minus 1. And we want to write that in quotient and remainder form. So before we do that, because polynomial division, it looks and acts a lot like long division was. So let's do a refresher, because chances are the last time that you did long division was a long time ago. So suppose that instead we were asked, what is 513 divided by 7? So this is a good problem for long division. And how do we do it? Well, we write it this way. 7, then under this little division radical, 513, which this is, by the way, called the dividend. The sort of the numerator is called the dividend. The denominator, what you're dividing by, is called the divisor. So the dividend goes under the division radical, and then the divisor goes on the outside. And we look at how many times does 7 go into. First, we just start with the very first digit. How many times does 7 go into 5? It goes into 5 0 times. Okay, that's not very helpful. If the divisor goes into the first digit 0 times, then you look at two digits, the first two digits now. So you ask yourself, how many times does 7 go into 51? 7 goes into 51 7 times, because 7 times 7 is 49. So we put 49 down here because that's 7 times 7. So how many times 7 goes into 51? 7 times. 49 down here, and then subtract straight down. What is 51 minus 49? Well, it's 2. Now bring down the last value, 3. How many times does 7 go into 23? 7 goes into 23 3 times, because 3 times 7 is 21. Subtract straight down, and we have 2. And now we've kind of gotten to the end. If you wanted to push this into the decimals, then you could. You would just put a decimal here, put a decimal here, make a little 0 here, because 513 is the same as 513.0000000. So you just keep adding zeros and bringing them down and doing this same process as long as you want. But what this is all saying is that 513 divided by 7 is 73 with a remainder of 2. So we would say 513 is 73, and kind of depending on how you're asked to answer this, you might be asked to just specify like 73 with a remainder of 2, or you might be asked to write it as 73 and 2 sevenths. That's what the remainder means. The remainder is 2, or like the remainder divided by the divisor. That's kind of how it operates. 513 divided by 7 is 73 and 2 sevenths. All right, how does this work for polynomial division then? Let's take a look. It's very similar for the setup. The divisor goes on the outside, and then under the hood goes the dividend. X cubed minus 3x squared plus 5x minus 6. Like that. And this time, rather than looking at the full divisor and seeing how many times we can multiply it into parts of this, we just look at the very beginning, this x term, and we ask, how many times does x go into x cubed? Or in other words, what do we have to multiply x by to make it x cubed? Take a second, take half a second, pause the video if it's not obvious to you. Well, x squared. If we multiply x by x squared, then it becomes x cubed. So x squared times x is x cubed. But we'll also take this x squared and we'll multiply it by the negative 1. X squared times negative 1 is negative x squared. And then same thing, we're going to subtract straight down. but I really encourage you at this step before you do the subtraction, put parentheses around this bottom row. Put parentheses around that and then put the subtraction sign. Why? Because this subtraction sign needs to be distributed inside. So it gets distributed to the x cubed, it gets distributed to the negative x squared, and then you're adding down. If you don't do that, it can be really easy to forget that this negative is being applied to this second term as well. So x cubed minus x cubed is 0. Good, that's what we wanted. Over here, negative 3x squared minus negative x squared. Well, negative 3x squared minus negative x squared, that's the same as negative 3x squared plus x squared. So this becomes negative 2x squared. And if you don't, at least for me, if you don't add these parentheses there, I can sometimes have the tendency to write, instead of down here writing negative 2x squared, which is correct, I might write negative 4x squared, because I might forget that this negative is out here, and then I might just add these straight down, and then I'm running into some trouble. Okay, so once we've gone through that, same thing like with long division, now we're going to bring down the next term, plus 5x, and then repeat. How many times does x go into negative 2x squared? Or, in other words, the equivalent question is, what do we have to multiply x by for it to become negative 2x squared? Well, we've got to multiply x by negative 2x. Negative 2x times x becomes negative 2x squared. And then push that through the divisor. Negative 2x times negative 1 becomes positive 2x. And then we just subtract straight down. Same thing over again. So negative 2x squared minus a negative 2x squared is negative 2x squared plus 2x squared. They cancel. We did that by design. 5x minus 2x. Ah, yes, 5x minus 2x is 3x. Excellent. And then finally, we bring down this negative 6. How many times does x go into 3x? Or in other words, what do we have to multiply x by for it to become 3x? We multiply it by positive 3. So 3 times x is 3x. 3 times negative 1 is negative 3. And then subtract these. 3x minus 3x is 0. Negative 6 minus negative 3 is negative 6 plus 3. So it's negative 3. And now that we've gotten to the end of this, this is the remainder. We have nothing left to bring down from up here, so whatever's left is the remainder. So what is all of this saying? This is all saying that x cubed minus 3x squared plus 5x minus 6 over x minus 1 equals, and we've been asked to write this in quotient and remainder form. So quotient and remainder form is, well, this top piece up here, this is the quotient. So the quotient is x squared minus 2x plus 3. The remainder is negative 3, but to write it in this polynomial, it's negative 3 over x minus 1. So this is the quotient and remainder form of this division problem. Notice though, just kind of a quick point to make, that I'm saying, by the way, that these are equal. This is a line of equality right here. If you can imagine, like all of this, it's on 2 different lines, but imagine multiplying this whole thing through. If I multiplied all of this through by x minus 1, I can say that this is the same as x cubed minus 3x squared plus 5x minus 6 equals x minus 1 times this quotient, x squared minus 2x plus 3 minus 3. Right? So it's also, although x minus 1 is not a factor of this, this also kind of gives you, polynomial division gives you a way of factoring a polynomial. Let's see here. So let's do one more example where things are maybe just slightly more complicated. And then we'll look at sort of the shorthand of doing polynomial division, which is something called synthetic division. All right, so let me see. Do I have a good example here? I just want to check to see if I have a decent example. Yeah, let's do this one. We'll calculate out 3x to the fourth minus x squared plus 7 over x minus 2. Let's do that and see what that comes out to. So we're going to start it off the same, x minus 2 on the outside. You know what, actually, let me make it just slightly more complicated. I'll just make it, because I don't think this goes in anyways, it doesn't factor. Let's make it a 3x. Yeah, there we go. I'm straying away from my notes, so that's always dangerous to do. Thinking on the spot is maybe not my strong suit, for better or for worse. I'm a deep thinker, but maybe not a fast one. Okay, so I have my divisor on the outside. Before I write the dividend on the inside here, one thing that I'll note is that, like, notice that on this dividend there are some sort of missing powers of x, so to speak. Like if we wanted to write all of the powers of x descending, this is missing the cubic and it's missing just the single x to the first power, right? Here's x to the fourth, x cubed is missing, here's the x squared term, the regular x is missing, and then there's the constant term. So when you're writing out polynomial division, when you're writing out the dividend, make sure to add in all of the descending powers. So how do we add in like the cubic and the regular x power? Well, we add them in with a coefficient of 0. So this is the same as 3x to the fourth plus 0x cubed minus x squared plus 0x plus 7. So starting with like the degree, every single descending power lower than the degree should be present. Our highest degree is 4, so we should have a cubic term, a squared term, an x to the first term, and then, well, the constant term. You don't have to add in the constant term, but all of the other ones need to be present. And now we can start doing this like normal. Okay, so how many times does 3x go into 3x to the fourth? Well, it goes in x cubed times. That is to say, x cubed times 3x equals 3x to the fourth. X cubed times negative 2 is negative 2x cubed. Put parentheses around it, subtract down. 3x to the fourth, those cancel. 0x cubed minus negative 2x cubed is positive 2x cubed because that's addition. Bring down the squared term. What do we have to multiply 3x by? Ooh, yeah, this one's going to get nasty fast. Cool. What do we have to multiply 3x by to make that 2x cubed? Well, let's see. What do we have to multiply 3 by to make it 2? 2/3. So plus 2/3 x squared. Yeah, this is going to get nasty fast. So 2/3 times 3x, 2/3 x squared, sorry, times 3x becomes 2x cubed. 2/3 x squared times negative 2 becomes negative 4/3 x squared. Subtract down. 2x cubes, those cancel. Okay, here's where we're going to test my powers of mental math on the spot for fractions. Negative x squared minus negative 4/3 x squared. Well, that becomes negative x squared plus 4/3 x squared. 4/3 minus 1 is 1/3. So this becomes 1/3 x squared. And we'll bring down the 0x plus 0x. All right. What do we have to multiply 3x by for it to become 1/3 x squared? Well, we would have to multiply 3 by 1/9. Is that right? Yeah, 1/9 x. 1/9 x times 3x. 1/9 times 3 becomes 1/3. X times x is x squared. Yep, great. 1/9 times -2 becomes minus 2/9 x. Lucky us, we have the 0x there, so this is going to be easy. The 1/3 x squareds cancel. 0x minus -2/9 x is positive 2/9 x. All right, and what are we bringing down now is the 7. What do we have to multiply 3 by for it to become 2/9? In other words, what am I trying to do? 3 divided by 2/9, is that right? So 27 halves? 2 over 27, right? Yeah, 2 over 27 times 3, because here, I better just write this out, geez. No, I can't do basic math. Yeah, I got my master's degree. I can't do basic math. Why would you expect me to be able to do basic math? It's unreasonable of you. 3, yeah, because here the 3 and the 27 will cancel, so that we just get a 9 in the bottom. 2, so yeah, 2 27ths. So plus 2 27ths. 2 27ths times 3 we just saw is 2/9. Excellent. 2/9 x minus 2 27ths times -2 is -4 27ths. Man, I picked some bad numbers. It's all because I added that 3 in. The numbers actually come out a lot cleaner if I didn't add the 3 in. Okay. Right, and then adding, subtracting down, 2/9, they cancel. 7 plus 4 27ths. 7 plus 4 over 27 is, what is 7 times 27? Well, 7 times 20 is 140. 7 times 7 is 49. 140 and 49 is 189. So 189 plus 4, or 193 over 27. Right? Hopefully I did my math right. 193 over 27 is the remainder. What a nasty, nasty little remainder. Okay, so then writing this in quotient and remainder form, we would say that this equals everything that I got there at the top. I'm trying to get everything on the screen at once. X cubed plus 2/3 x squared plus 1/9 x plus 2 27ths plus, let's see, what would this last piece be? It would be 193 over 27 divided by 3x minus 2. So plus 193 over 27 times 3x minus 2, right? Hopefully I did my math right. This is the trouble of doing things on the fly, especially with math, because if you say something wrong as a math teacher, it just confuses the hell out of everybody. How can you check this, by the way? Do you know how you can check to see if I did my math right? If you have a graphing calculator or Desmos. If I was faster at switching my screen, I would pull up Desmos really quickly here. But what you can do to double check yourself on this, graph the original rational function, graph this thing, they should come out to be the exact same graph, assuming I did my math right, which is questionable at this point. Okay, the very last thing that I want to show you, just very quickly, this comes out really quick, is, we'll do the original problem, but I want to show you something called synthetic division. So synthetic division, it is polynomial division, but it's like a shorthand method of doing polynomial division. There are 2 requirements, though. You can only do synthetic division if the divisor is linear with a coefficient of 1. So not the constant term, but the coefficient of 1. So like this example right here, I could not use synthetic division on it. The divisor is linear, but the coefficient on x is not 1. So I can't do synthetic division there. You could, but you'd have to divide through by 3 first, and it will just turn nasty. So let's do the original problem that I had, which was 3x to the 4th minus x squared plus 7 over x minus 2. So just removing the 3. Remember, I just kind of tossed the 3 in because I was like, wait, I want to make this harder for me. Yeah. So here, now we have the divisor that is linear. The coefficient on the divisor is 1. So this is a candidate for synthetic division. Here's how we set up synthetic division. So on the inside here, we kind of make like it's sort of like an inverted division radical. This sort of like, I'll call it a box. We make this sort of box thing. Inside of the box, we're going to put the coefficients of the dividend. But just like with regular division, how we had to add in coefficients if like certain terms weren't there, you've got to do the same thing here. All of the terms have to be present. So 3, the x to the 4th coefficient is 3, and that's all that you have to write is the coefficient. There's no cubic term in here, and maybe I'll just, as a note, I'll write up here that this is an x to the 4th term. That'll be helpful for me later when we get to the end. There's no cubic term, so I still need to add in the cubic term. It gets a coefficient of 0. The coefficient on x squared is what? It's -1. Be careful, it's -1. The coefficient on x is, again, 0. And then the coefficient on the x to the 0th term, aka the constant term, is 7. Right? So that's what goes inside the box. Outside the box is where the divisor would go, but I'm only going to put the constant term, but I'm not going to put the constant term as it's written, because what I want to do, like previously with polynomial division, is on these steps you're subtracting them. It's kind of tougher to do the subtraction, so instead what we do is we make this negative, and then we add straight down. So rather than writing -2 on the outside over here, I'll write a +2. Notice also that like if this was a root, if x minus 2 was a factor of this, which it's not, it leaves a remainder, but if it was, then 2 would be the root. In any case, here's the big setup. And the reason that we need the coefficient on this term to be 1 is so that we can do this first step here. The first step of synthetic division, once you've got your full setup here, take this first coefficient and just bring it straight down under the box. 3. It just comes straight down. You don't do anything, just drop it down. Now what we'll do is very similar to what we were doing previously. It's similar, but it's slightly different. In essence, it's the same thing, it's just shorthanded. So what we'll do is 2, take the number on the outside of the box, 2 times 3, your newest number, take that product and put it in the next column. So 2 times 3 is 6. I'll write a 6 in the next column, inside the box. And now add straight down. 0 plus 6 is 6. And then repeat. 2 times 6 is 12, so 12 goes inside the box. -1 plus 12 is +11. 2 times 11 is 22, goes inside the box. 0 plus 22, 22. 2 times 22 is 44. 7 plus 44 is 51. Okay, we've finished this, but what does any of this mean? This bottom row is the quotient and remainder. But what are the sort of the variable terms that go along? These are just the coefficients. What variables go along with it? Well, the variable that each of these coefficients receives is 1 degree less than the coefficient, the variable of that column. That's why I kind of put this x to the 4th here. So down here, this row, take whatever power this is, like this is x to the 4th, here's x cubed, x squared, x, and then this is just the constant term. Each of these get a power of x that is 1 less of this column. So this is the x to the 4th column. This becomes 3x cubed plus 6. This was the cubic column, so it becomes x squared, right? Was x cubed, now it's x squared. plus 11x plus 22 plus a remainder of 51. How do we write that? 51 over x minus 2. Okay? And that's the solution. This right here is 3x to the fourth minus x squared plus 7 divided by x minus 2. All right? So that is synthetic division. Again, the big thing with synthetic division is you've got to make sure that the divisor is linear and that the coefficient on it is, on the x term, is 1. If neither of those, or I should say if one of those is not met, you have to do the long polynomial division. So there's that. If you have any questions at all, please let me know.